Although the solar energy flow is the most dominant flow, it is not the only source of energy on the Earth. Energy from the use of nuclear fuels, as well as energy due to the tides and the thermal energy from the center of the Earth, all contribute to the total energy on the Earth. Although these flows contribute much less, they are still vital to ensure that the Earth is in an energy balance.
From the 174,000 watts delivered to Earth, an average value of 1,367 watts per meter squared is determined to be the power incident on 1 square meter located at a fixed location outside Earth's atmosphere. However, this value averaged over the entire planet becomes 340 watts per meter squared. Of this power, approximately 30% is reflected back into space, with reflection due to the atmosphere, clouds, the ocean, land, and ice.
The remaining 120,000 watts, or approximately 70% of the initial energy that reaches the surface of the Earth, comes down and warms the atmosphere. This portion of the pathway can be seen in the picture below. In the atmosphere, greenhouse gases, molecules absorb this thermal energy and their temperature rise. After this absorption, the gases radiate thermal energy back out into all directions. This thermal energy then radiates back out into the space. It is the phenomenon that warms the surface through the natural greenhouse effect. Approximately 78,300 watts of energy are used to keep the atmosphere warm in this manner, resulting in the average temperature staying at 15 degrees Celsius or 288 degrees Kelvin.
From the original incoming energy, approximately 23%, or 40,000 watts, evaporates water and runs the hydrologic cycle. Here, liquid water molecules absorb incoming energy and change phase from liquid to gas. The energy it took to evaporate this water is then latent in the motion of the vapor molecules. The molecules can then condense, creating rain, snow, and sleet, which drives rivers, runoff, and cloud formation, then releases the latent heat into the atmosphere. This allows hydropower to capture energy as well, of which humans use about 1 watt. Roughly 1%, or 1,700 watts, is turned into the energy of wind and ocean currents. This moves air and water all over the planet, which transfers the heat held in the motion of the molecules of the gas or liquid.
A very small amount, only around 0.08%, or 140 watts, of the initial energy gets captured by photosynthesis, giving energy to plants. This photosynthesis then allows plants to absorb carbon from the atmosphere in the form of carbon dioxide. Almost all the energy used to power life comes from this 140 watts. Plants get their energy from this photosynthesis, and then animals either eat plants to get this energy or eat animals that eat these plants to get this energy. When the plants and animals die, they become fossil fuels. However, it takes a significant time, millions of years, for this to occur. Although the formation of fossil fuels isn't straightforward, most of the chemical energy stored in these plants and animals decays into thermal energy in the atmosphere. The fossil fuels used by humans amount to about 14 watts of the 16 watts of primary energy used by humans.
An example of this 3 or 4 link process is algae eaten by a snail, which is then eaten by a painted turtle, and that is 3 links. But say the turtle dies of old age, then a crawfish eats part of it, bacteria and fungi eat the rest of it, and then they decompose the turtle to get the energy left in its body, which equals 5 links. The cycle of energy through all living things on Earth is quite simple. It goes plant to a plant eater to a meat eater.
Energy travels in straight lines through food chains and webs and is used up and is replaced by photosynthesis using sunlight. Nutrients, life materials, travel in circles that do not end. Nutrients have been recycling on Earth for billions of years.
Thanks for watching, and Mr. Block, give us an A.